guys, hopefully everyone is fine. In today's video, we will be discussing about how language will be converted to grammar. It means our language is given to us with input symbols. We have to generate grammar rules for it. The first question you can see over here is let L is a set of all palindromes over A and B. It means you have to generate strings belong to A comma B that are set of palindromes. So firstly, let's generate the strings and then we will generate rules. The first palindrome I can have in my mind is all sets of A's and B's including null. Null can be one palindrome. A can be one palindrome. B can be one palindrome. A can be one palindrome. B can be one palindrome. A can be a palindrome. A B. There are so many infinite palindromes, so you're not going to write all of them. But it's very important to just find out how you can generate rules. So as I told you, the minimum possible strings, you can take them in your note was minimum possible strings can be taken in the terminating rule. So guys, if I talk about minimum possible string, null was one of them, A and B are one of them. You can easily create S is generating null as well as A as well as B. Now I have to think. Now just think over here with triple A and let's say triple B. If I just place S over here and S now has three terminating rules, which is null, A and B. If you put null over here, what you will get? A you have written ASA means ASA you have written and you put null over here. If you put null over here, what you will get? You will get A null A, which is double A, right? And you are getting a string double A. If you put A over here, you will get triple A. If you put B over here in place of this S, you will get ABA. So ABA is you are getting A you are getting clearly. Your next rule can be ASA. If it is starting with A, ending with A, it starts with B as well. It can end with B as well. So this is the clear rule of your palindromes. This is a set of palindromes that you have. Hopefully, this part is clear. So this is my right answer. So I move to the next particular question. The question says that you have a language. Language is given to you with WCWT, where WT is a reverse of W, and W actually belongs to A comma B whole star. Means W contains all values of A's, B's, and any combinations of A's and B's. Means it's like A plus B whole star in the form of your regular expression. So W contains all values of A's, all values of B's, any combinations of A's and B's. So how will you generate strings? It's very simple. You can start with minimum possible values. If W belongs to A comma B whole star, the minimum possible value of W can be null. So if you put null C, what is nullity? That is again null C as well as null reverse is null. So anything concatenated with null is anything. So minimum possible string that you have got is C. Just put A over here in this because W can contain single A also. A, C, and what is the uh, reverse of A? Reverse of A is going to be A only. You put B over here, you will get BCB. You put double A over here. So double A, C, A reverse is double A only. So it will have double A, C, double A. You can put AB over here. You can put AB, C. What is the reverse of AB? BA. So you'll get, similarly, you get BBC, BB, and BA, C, AB. So you are getting this particular result. Guys, if you think properly, if C is not one included, what it is giving you? If this C, just C over here, if it is not included, if it is not included, this is AB, this is BA, this is BB, this is BB. Clearly, it is giving you a palindrome. So minimum possible answer that you have got was C, which you will include in your rule, right? But for other parts, if you just put S over here, if you just put S over here, the S value you see obviously, but if you put S over here with, or you put S over here, guys, ASA. ASA means I can clearly write ASA. S value can be my C, but this S value can also be written as ASA over here, right? So if I put S value as C, I will get AACAA, which I am getting over here. If I put just C value over here, I get ACA also. I can also get, guys, BSB also. So if I put just C value over here, I'll get BCB. Or if I get BSB over here, I can easily put C over here. We get BBCBB. So we are getting these answers exactly what they are required. I can clearly write A as A and B as B. This is a set of palindromes. Yes, there is one difference. There is a C which is intermediate used. Hopefully, this thing is clear to all. Fine. Now, the next question that is given to us is, it is saying that language is generating as ANBN C of I and n is greater than equal to 1 means n must be present and I is greater than equal to 0. Now, how we are going to counter this kind of thing? Now, in this particular case, we have got a power n, b power n, c power I. So I'll just rather generate the strings. I value can be 0. I can take n value as, let's say, 1 and I value as 0 and just generate the strings. I will get AB, right? I value, I have taken it as 0, right? If n value is equal to 1, I have got this answer. If n value is 2, I will get AABB. C value, I value, I have taken it as 0. I will get this answer also. Triple A, triple B. So many things. Guys, this is where n is greater than equal to 1 and I is equal to 0. These are those strings. What if my n value is greater than equal to 1 and I value is 1? So I will get what? I'll get ABC, because I will get this, and n greater than equal to 1 means I'll take n value as 1, then I value as 1. So I'll get A, A, B, and then C value as 1. So I will get ABC. I may get A, B, B, C. I may get triple A, triple B, C. So many answers. Guys, again, N and I are not related. I may get this answer also, ABC square, A square, B square, C square. I get A cube, B cube, C square. So many answers I can get. Now, this is a very huge kind of answer. But firstly, we have got the language as A power n, B power n, C power I, and n is greater than equal to 1 and I is greater than equal to 0. The main important thing is these are not related. So I am getting the strings as, this is with I value as 0 and n is greater than equal to 1. This is with I is equal to 1 and n is again greater than equal to 1. And this is with I value is equal to 2 and n value is continuously improving. Right? Now, it means there is clear, we have to get this answer also without involving C. So can I write a particular rule as S is generating A and your A is generating AB slash AAB? This I can write, right? This I can definitely write. But again, the point is that I must use it very judiciously to basically solve a particular question where I have clearly written this particular scenario with S is generating AB over here. And again, this value is improving only for I is equal to 0. But what if I value is equal to 1? How should I write those answers? So this is also a recursive call, na? This is also a recursive call where C value is increasing and this whole particular part with this small c, which is getting included after this particular part. So I may write S is generating A and A is generating AB, but this is for I value is equal to 0. But what if I value is equal to 1? Or I value is equal to 2, it means that those things we need to be considered with can be giving A, and A can be AB as well as AAB. Why? Because for this value, for I equal to 0 and n greater than equal to 1, we will get only these strings. S is generating A and A is giving us this answer, right? AB slash AAB. The if I am putting S is generating A, so A is also giving us AAB. If this A is terminated with AB, so it will give us double A double B. So we will get this particular string. Now I can also write S is generating as SC. Why? Because you see over here, C square, C cube, these values, and S is generating SC generates again SCC. It can also generate SCCC. So S value you can take it as either AB or AAB. Again, the recursive call you can call, and this result could be like this. So I would clearly say S is generating A is generating AB, AAB. This is for n greater than equal to 0, I is equal to 0. But S is also generating SC. This is for n greater than equal to 1 and I greater than 0. Because over here we can put the value of C in the end. Hopefully this is clear to all. So we have the next question with okay. So we have the next question. Again, it is given as a power j bn cn n greater than equal to 1, j greater than equal to 0. So n and j are not related. So I'll just take the case with j is equal to 0 first, right? If j is equal to 0, I will get bc. I will get b square c square, b cube c cube. So many answers. So clearly, I can easily create a rule of S is generating capital B and capital B is generating BC slash BBC. This rule would create these strings. How? You can easily try to get it. If S is generating B and B is generating BC, so I will get BC string first up. I can write S is generating B and B is generating BBC. I can put BC over here. I'll get B square C square. I can get I can put BBC over here. I will get B cube C cube. So clearly this rule I have got over here, right? Now again, I have to see J greater than 0. In this, I can clearly get A, B, C, right? I can get A, B square, C square. So many answers. I can get A square, B, C. I can get A square, B square, C square. So many answers. So again, it means this is also a recursive call. So I would rather write S is generating AS Now, AS would repeat this particular case with A as a recursion with S is taken as AS. So I will get A single AS, two A's S. So clearly the answer of this question would be S is generating AS. S is also generating B. B is generating BC slash BB. This is the particular answer of your uh, grammar from the language. Now, there is a question which is given to us. Grammar is given to us, and we have to prove that this language actually, this grammar actually belongs to this language. So clearly, your S value is given to us as S is generating 0 as A1, 2. S is generating 0, 1, 2 is the terminating rule. So we have to prove. Now, clearly, you have written it as S is generating 0 as A1, 2, right? Clearly, you have written 2A1 is generating A1, 2, and this is a context sensitive grammar, guys, right? 1, A1 is double one. So I can use this particular thing to prove this thing. We have already got S is generating 0, 1, 2, which is the starting of this. So A1 value we need to put 2A1 value is A1, 2. Fine. So how we are going to go about it? I can easily put this West value as 0, 1, 2. We have got A1, 2. So clearly your 2A1 is generating what? A1, 2, right? Your 1A1 is generating what? Double one. We've got 0, 0, 1, 1, 2, 2. Earlier you had 0, 1, 2 as a string. Then you have 0, 0, 1, 1, 2, 2 as a string. So clearly your language is followed as 0 power n, 1 power n, 2 power n greater than equal to 1 because minimum 0, 1, 2 are available. Hopefully this is clear to all. Fine. So we have the next question. Clearly, this question is given as we have to check whether this string is belonging. So this is a derivation of whole stuff. So we have to us as B double A double B A B triple A double B A B. So we have to basically check this thing. Now, obviously, you have to start from a particular starting rule. So starting rule is clearly telling us that it is A1, A2, A. Clearly, I'm not starting with A. So I have to use that rule that gives me BAA at the start. So we have one rule, which is AA1 is actually deriving BAA. So I'm writing BAA over here with A2A. Now, what we have to use the rules accordingly to get the answer. Clearly, your A2 will give us certain answers. It is giving us BAA, A1, ABA. So this answer is giving us this particular part. Now, A1 might give us different answers. So you just check A1. You have BAA. A1 is giving you BA, A1, A2, B, and we have got ABA in the last. Clearly, your AA1 is providing you with double B double A. We have got A2, B, ABA. Now, your A2 is providing us with A1, AB. It is A1, AB, then B, AB, A, and we have got BAA, double BAA. Now we have got BAA, double BA. Now clearly double BA. Now I have to use this particular rule. This particular rule is giving us, just see, I'm writing it here. It is BAA, double BA. Then AA1 is giving us BAA. Then again ABB, ABA. Clearly, the string, whatever we desired, we are getting this from these particular rules. So clearly, these grammar rules are generating this particular string. So we have the next question with us that consider the grammar is given as this grammar. Test whether it is belonging to 00112 or it is belonging to 0011122. Clearly, it is giving a 012. That is my starting grammar. Now I have to check whether this grammar or this grammar it is belonging to, or this language it is belonging to. I can use a rule of S is generating as AS1, A2 because you can generate strings from recursive rules also. You can write this S value as 012 A12. Clearly, your 2A1 is generating A12, right? And your 1A1 is generating 001122. Clearly, this answer is formed. It means this is belonging to this particular string, then this particular string. So answer is 01122. The string is generated and this grammar is 011 and this language is 0 and 1 and 2 and n greater than equal to 0. So this is how it is proven. So this is up from my side regarding your conversion of grammar to languages and languages to grammar. Thank you very, very much, guys. Keep supporting.